This is the formation and life cycle of stars. The formation starts as a giant cloud nebula. As a catalyst flies by, the core of the nebula begins to collapse into itself, forming a protostar. The cloud around the protostar will continue to collapse into itself, creating rings around. As star life progresses, though, 90% of all stars form brown dwarfs. And then further over time, it will form a fully fledged star. Much more is required, though, for a star to continue its evolution process. As it requires much energy to do this, the star will break down elements into different elements on the periodic table. This is known as exothermic reaction. As you can see, all of these reactions are needed to continue the life cycle of the star. As exothermic reactions end, anything after iron will be known as an endothermic reaction. Everything after exothermic reactions are not as important to the star's evolutionary process, but are still done over time. Both are completed through a process known as nuclear fusion. Temperature will rise on the star to 15 to 20 million Kelvin, causing fusion and a proton-to-proton change. 500 million pounds of hydrogen and 495 million pounds of helium. Pressure will rise. Density rises as pressure goes up. As density goes up, mass goes up. Let's take one last look at the reactions before we move on to the different types of stars. As you can see, a lot of work is needed to be done. Further evolution of the stars can result in 3 different ways. These can range from a low-mass star to a medium-mass star to a high-mass star. We'll start by talking about low-mass stars. Low-mass stars fuse through helium, which then form into red dwarfs. Red dwarfs have a potential to be immortal because of their low energy burn rate. It is still unknown, though, if red dwarfs can be considered immortal because they are still burning through energy. Next, we will be talking about medium-mass stars. Medium-mass stars fuse through oxygen and form red giants, yellow dwarfs like our Sun, and main-sequence stars. Their evolution continues through either the shell or the core. Shells form supernovas, which create nebulas. Cores make white dwarfs, which make black dwarfs. Next, we will be talking about high-mass stars that fuse through iron. These form hypergiants and blue supergiants, and further evolve through the shell or the core. When evolving through the shell, they form supernova type 2s, which in name is larger than supernova type 1s, and form nebulas, much like medium-mass stars. When continue its life cycle through the core, though, they form white dwarfs, which create neutron stars and pulsars, which later form black holes, thus completing the evolution and life cycle of all 3 types of stars.